Hey, I'm my JavaScript friends. This is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript. This video, we're going to be covering our DICE project, and specifically the test for our test-driven development. If you like this video, please click on the like button below. Click on the subscribe button to subscribe to this channel, or leave a comment. I'd love to hear from you. So the first thing we want to do is develop the test for our DICE system. And that will help us determine the design of our project. So I've already done an npm init, so what I want to do is let's go ahead and install the things we're going to need. And what we really need, in fact, the only thing we need is our testing engine. So we will do npm install, save dev, Cypress. We'll be using the Cypress as our testing engine. And I'll see you on the other side. Okay, we're done with that. So the next thing we want to do is let's set up our test scripts, because this is the default test script that they give you when you do an npm init. So we're just going to pop in the ones we're going to need here. This is going to be able to give us a Cypress run, which will give our test E2ECI, and our test E2E will just be our Cypress open. Now, we do need to do a Cypress open to make sure everything is initialized correctly. Now, I've done a lot of Cypress on this computer, so this may not do much of anything, but we do need to run it, or you'll need to run it to make sure that Cypress has been completely installed. So do a test :E2E, and that will do the Cypress open. As you can tell there, it says, this looks like your first time using Cypress 10.6. Oh, they've upgraded it since I last used Cypress. So there we go. This is basically exactly what you would see when you're trying to install Cypress. So once it's done, I'll see you on the other side. Okay, once you're finished, you should have a welcome screen that says welcome to Cypress with all this kind of fun stuff here. What we want to do here is we want to click on not configured on the E2E testing, and it will give us some sample Cypress config.js files, Cypress support E2E files, fun things like that. This is all fine, fun, and good. So let's just go ahead and click continue. That's going to create some Cypress information. We want to do we care about browser? Nah, we'll just do browser, Chrome. And once you answer all the questions, that's the kind of stuff that you'll get. We're going to stop it at this particular point because we're going to put our own testing in. So we'll just exit out of that. We're also going to exit out of this. And that completes completes everything here. Now, I do want to show you one thing that happened to me. And this is the first time this has ever happened to me. I did get an error here saying Cypress verification timed out after it looks like your first time using Cypress. It says looks like I'm running Cypress binary directly. I was not, so I'm thinking I thought this error message was a little strange. So I did it again, and it worked this time. So I just kind of want to make you aware of that. If you do get an error, just run it again. At least in my case, it seemed to work okay. So now that we've got Cypress all ready to go, if we go back over to our IDE, okay, you can see that we've got a Cypress directory here, in which case we got a downloads of fixtures and support. I'm not going to go through exactly what all these mean because we're not going to use them in this case, but you can look at the Cypress documentation online. It gives you everything you really need to know about it. What our concern here is the Cypress config.js. Nothing here, and we're not going to add anything to it, but what's important is this E2E right here. This defines how we do the E2E configuration for Cypress. And what that will entail is basically creating an E2E directory under the Cypress directory, and then putting all of our tests there. And the test basically is the test name.cy.js. That's the default name for all of our tests. So this gives us everything we're going to need to at least start creating our test. So let's just go ahead and start creating our test. See what happens. The first thing we need to ask ourselves is, what are we going to support? Well, we're going to support, obviously, rolling the dice. And the dice is going to be in the XDY format, where X is an optional number that tells us the number of dice to roll. And if it's not specified, it's going to be the number 1. D is just a regular D, which is basically the operator saying, hey, we're going to be rolling dice. And the Y is going to be the number of sides on that dice. So 3D6 is 3 6-sided dice. 2D10 is 2 10-sided dice, and so on and so forth. So we have that, but since we're doing equations, I want to do the very basic support. I want to support plus, addition, subtraction, multiplication, division, and parentheses. I also want to make sure I get the precedence correctly. So let's go ahead and take a look at what one of our sample JavaScript files are going to look like, or one of our sample test files are going to look like. Let's just work with addition. That's going to be the very easiest one to do. So the name of our file is going to be addition.cy.js, and that basically is the default that Cypress uses to know that it's a specification file, and that's why it's named that way. So we're going to basically want to be able to support a plus sign. So what is the syntax going to look like? Well, the basic syntax is that we're going to have a string, and once we interpret that string, we're going to need to be able to make whatever evaluations we want on it. So that string may look something like 3d6 plus 4. It could look like 4 minus parentheses, well, 4 times parentheses 5 minus 1, or let's just make it 5 2d10 plus, or divided by 4 minus 1d6. You know, any weird stuff like that. But the idea here is obviously we're going to need to be able to have the precedence set. We're going to need to be able to do parentheses, multiplication, division, addition, subtraction, all those kind of fun things. So the idea here is we parse out this string and we figure out what we need to do. Real simple, not a big deal. So let's take a look at some of the failures, or excuse me. So let's take a look at what our code is going to look like. So I'll see you later. Okay, so here's what our code will look like. We're going to be importing dice from our source directory, which we haven't created yet, so obviously it's going to blow up. But here's the test that I feel need to be worked on if we're going to do addition. So for instance, if we just pass a plus sign, we should be able to throw an error. If a plus sign is the first sign in the equation, we should throw an error. So for instance, you know, let me just expand this out. So the equation is that we have a plus sign in as the only thing in the equation that it should blow up on us. Dice.roll is what I've decided to call the method, and it's going to be a static method, which means that this class is going to be a static class. I'm basically just like the math class is. If you're used to, if you're used to using math inside JavaScript, you could say math.floor, math.random, but you can't say new math. Same thing with this one. I'm going to say dice.roll to roll the dice, and then we'll pass the equation to the roll method to be able to do whatever we have to do. But I'm not going to allow them to instantiate the dice method. So we passed the plus sign. We should be able to get some sort of error. If we pass a plus 4, that's an invalid equation, at least from what I'm working with here. So we're going to throw an error. The operator, the plus sign, should not be at the very end, so we're going to throw an error for that too. This is a good number, so we should return the number 3. So if I type in 1 plus 2, we should return the number 3. Real easy. And you see, these are really easy. Here's the result, and I should expect the result to be a certain value. And then finally, we're going to do floating point numbers to make sure that we can actually add floating point numbers. Everything I had done before was with integers, so now I just want to make sure I can do floating point numbers too. And I got a little message here. We use toFixed in the test below to make sure the IEEE, to take into account IEEE precision issues. If you ever encounter this, you can do things like just weird thing. You may get a number, you may do a division or multiplication or whatever and get a number. Instead of getting number 4, you may get like 3.99999999991. That's an IEEE precision error that all computer programs have, because that's just the way the IEEE floating point specification works. It's not perfect in its calculations, but it's extraordinarily close for government purposes. So I use the toFixed down here to be able to make absolutely certain that I'm going to get the right number, that there's no precision type problem, so that the test won't bomb out on me. And that's pretty much it. By itself is invalid. At the very beginning of the equation is valid. At the very end of the equation is valid. If it's right in the middle of 2 operands, it's perfect. And I can test both integers, and I'm testing floating point numbers. So that's really all there is to the addition test. And the subtraction test, the multiplication test, and the division test run the exact same way. So let's create a file called subtraction .cy.js. And let's take a look at the subtraction one. Okay, and here's the code. And notice it looks exactly like the addition one. In fact, as I was going through this just before I started recording, I'm sitting here thinking, do I really need to have all these tests? If I tested it for one, I shouldn't have to test all the rest of them. Well, I did it anyway. I went ahead and kept it in there just to show you, hey, if you want to fix it, you know, do a pull request. Let's get it fixed. So if the error, if the minus sign, if the subtraction sign is first, we throw the error. If it is, or by itself, if it is first, we throw the error. If it is last, we throw the error. We should return the number 3, 5 minus 2. So we use 2 fixed. We're just going to do another floating point number here to make absolutely certain that works. So we should be able to get 3.4, and that's pretty much it for subtraction. Multiplication and division are the same way, so let's go ahead and just pull those two in and see what they do. Okay, so we got multiplication and division in there. It's all the exact same thing. The big thing here is make sure that if I multiply two numbers together, I get the numbers that I've actually expected. No big deal. Division, same thing. By itself, first equation, last equation, make sure I get the correct number, which is 12 divided by 2. Okay, so I've done multiplication and division. What else are we going to support? Well, we're going to support the use of parentheses. That's going to be critical. We're going to be supporting the use of precedences and the dice roll. So let's go ahead and let's tackle the parentheses. Let's throw that code in there real quick. Okay, and by the magic of television, there it is. So with the parentheses, all that we're really doing here is we're checking to make sure if all the syntaxes are correct. So if we have an open parentheses, we want to be absolutely certain that if there's only just one set of open parentheses, then we're going to throw some sort of error. We next want to check to make sure is that if we got a mismatched pair of open parentheses. So in this case, I've got an open parentheses and a closed parentheses, so that's great, but I also have another open parentheses, so that should also error. And then finally, if they match up, the 3 and the 4 match up, then it should correctly evaluate the equation. Then I want to check the close one, and the only extra one to check on the close is if I have an extra close that we didn't need to have, that we didn't have before. You know, we should throw an error if the close parentheses comes right after the operator. Because the close parentheses can never come right after the operator, it must come after an operand. So if it comes after any operator, boom, it dies on you. Okay, on the mismatch, let's see what we got here. What if we have more closes than more open than close? And if they're in the wrong order, we blow that out of the water. And if we have more closes than opens, oops, there it is. If we have more closes than opens, whoop, blow that out of the water too. So in this particular case, we only checked one time whether it's a good equation or not. All the rest of them were just to make sure we can get the correct error conditions for the parentheses. Alrighty, let's take a look at the precedence. That's going to be a good one. And through the magic of television, here is the operator precedence. So what exactly is precedence? So precedence is the order that you want to calculate. So for instance, if I had 1 plus 2 times 3, for example, the times takes precedence over the plus. So the first thing we do is we don't do 1 plus 2, we do 2 times 3. So it's very critical on, as we'll get to the stacks here with the next video, it's very critical to understand the precedence so that as we read in the operators, whether they're subtraction, multiplication, addition, or division, or parentheses, we know whether we need to go ahead and make calculations on the current stack or we can just continue to stack it up. So for example, if we had 1 plus 2 times 3, we know that when we get to the multiplication, we got to keep on going because multiplication has to be done before the plus is done. But if we had 1 plus 2 plus 3, when that second plus comes in, it has the same precedence as what's on the operator stack. So therefore, we'll do the first 1 plus 2 calculation first before we continue to stack on the rest of the equation. So the whole idea, and of course, parentheses is a whole different story. That just stacks and just, you know, is precedence over absolutely everything else. So no big deal. So the idea here is that by setting up these precedence rules, we can ensure that we make the calculations correctly. Like everything in sub parentheses is calculated first, then multiplications and divisions are calculated, then addition and subtraction is calculated. And so that's what all of this information here is I want to make sure that we return correct results mixing all the different combinations that I know of. For instance, there's a combination of multiplication and division, and it's just real simple by putting in the correct equation and just testing, manually calculating out and testing it to make sure it's correct. So I'm mixing multiplication and division. So in this case, I meant to say this. So in this case, we're going to do 2 times 4 first, which is going to be 8. Then the next thing it's going to do will be the 3 plus 8, which will be 8, 9, 10, which will be 11, and then the 11 plus 6, which will be 17. Then we're going to be mixing multiplication and subtraction, which is the exact same thing we had up there, except now we got subtraction in there. Division and addition. Division and subtraction. Multiplication and division. So how's this going to work? Well, once we're going to do the 12 times 2. When the multiplication comes in next, it's going to realize that it has the same precedence level as division, so this will be done first, the 12 divided by 2. So when 12 divided by 2 is done, that's going to be 6. Then 6 times 3 is 18. So that's how the precedence work when you had the same precedence. Plus and minus has a lower precedence than multiplication and division, and that has a lower precedence than parentheses. So also we have plus and minus. There's the plus and minus. Then we should return a correct result mixing parentheses and other ones. So this is a much larger equation. 2 plus 3 times, so basically what will happen here is we'll do the 3 plus 4 first, then we'll do the 2 times 3, and then we'll figure it all out from there. I'm not gonna worry about it. I've got it figured out manually. Here's where we return the correct result with multiple parentheses. And what I mean by multiple parentheses is that, I should say nested there. The better word is nested. Let's change that word. I don't like that word. There, okay, with nested parentheses. And so here are some nested parentheses. I want to make sure that I can actually handle the nested parentheses also. Okay, so I should return the correct result if I'm mixing my dice with other different operations. And here's an example of what a dice roll would look like, a 3 dice 6. And then finally, if I have multiple ones, like here's a dice 6 plus a 2 dice 6 plus a dice 6. And that's kind of stupid, obviously, but I could have just said 4d6, but again, the idea here is I'm just checking to make sure everything is correct. So that takes care of all the precedents. So that takes care of everything except for the dice. So that actually ended up being the very easy thing and was the impetus for this entire series to begin with. So let's take a look at the dice. Okay, and here's my dice code. And remember, our format is going to be XDY, where X, let's just do this, where X is equal to the number of dice, which is optional, default 1. D is the letter D, which basically, if you think about it, it's kind of like an operator, like addition and subtraction. And then finally, Y is the number of sides on a single dice. So again, 3d6 will be 3 6-sided dice. 2d10 will be 2 10-sided dice. 1d100 will be a 1 single 100-sided dice, or even just simple d6 will be a single 6-sided die. So let's take a look at the different tests we're going to run. First of all, if always specifies the letter D, it should throw an error because I don't know what kind of sides. The first number is optional, but the second number is not. So if all I do is specify D, it doesn't know what heck's going on. If the D is the last character, or the last character in the equation, which basically means that if I had the number of dice and the letter D, but I didn't say what sides, that's also going to be an error. We're going to throw an error if the number before the D is not an integer. You can only have integer numbers before the letter D, so any kind of floating point numbers after the letter D cannot be done. Throw a number after the number after D is not an integer. Same thing here. A floating point number, you can't have 6.6 sides to a dice. Now, in actuality, we do have computers here, so in reality, we can have a 6.6 sided die. We can have a 10.41 one three-sided die. We can have a pi die, 3.1415, blah, 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 blah. So we can have a pi die if necessary. But I'm making it simple, so I'm going to say, hey, that number after the letter D must be an integer. Okay? We're going to throw an error if the first number before the letter D is less than 1, because it doesn't make any sense to have zero-sided die or a negative-sided die. That's just stupid. So the number on the left-hand side of the letter D it must be 1 or greater, or not be there at all. So I put a 0 there, so that should have errored out. We're going to throw an error if the number on the right-hand side is less than 2. Because it doesn't make sense to have a one-sided dice or a zero-sided dice. So we want a sided dice that's either two-sided or anything greater than two-sided, like, I don't know, like Math.Infinity two-sided. Yeah, 2 infinite dice. That'd be a fun thing to figure out if JavaScript will just die on that or not. But it doesn't really matter. Okay, so we've thrown all the different errors that we could possibly think of with a specifying a dice. So let's actually make sure everything is correct. So if we roll a die 6, we should expect a number greater than or equal to 1 and less than or equal to 6. And this will basically roll or test to make sure that we do roll a correct dice if there are no numbers in front of the letter D. Okay. This will make sure if there are that the number of dice that we have, or the number of sides that we have specified is the correct side. So we're doing 1d6. So our result should be between 1 and 6 inclusive. Here we're making sure our multiplication is working, so our result should be between 2 and 12 inclusive, because two-sided dice, you're going to have a 1 and 1, that's 2, it's the lowest number, or a 6 and 6, which is 12, which is the highest possible number. And then finally, we're going to make sure that you can use the letter D, or upper or lowercase d. I don't know why, but I did it anyway, so I just want to make sure that the uppercase D also still works. So that will cover all of our dice. So what have we covered? Well, we've covered our dice, what we're seeing on the screen right now. We've covered addition. We covered division. We've covered multiplication. We covered parentheses. We covered precedence. And we covered subtraction. So that should be all of our test. I'm not going to run the test right now because we don't have any code whatsoever to run test against. But this basically tells me now that for this dice game, or this dice rolling library, all we're going to have is just a single static method on a static class that we pass an equation to, and it'd be our responsibility to parse out that equation. If you saw the previous video, I gave a brief introduction to how the double stack is going to work, where you have an operator stack and an operand stack. So that's pretty much it for this one. I guess the next video is going to be the video where we write the code to match the specifications that we have specified here in our test to make sure all the tests work correctly. Yay! Hey, if you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. And that's all there is for this particular video. This is the Virtual Void, aka Mike Smith. We'll see you later.